All right, let's start with this today. You don't have to copy this part down. But... All right, let's say I throw that up on the board. And I say, solve it for me. Solve it. What are you going to do to solve it? 3. How are you going to solve this? Okay, name 2 things you're going to cross multiply.
X and 8.
Okay, oh, done. You're going to cross multiply x and 8, right? And get 8x. What you just cross multiplied actually has a name. The values that are in these 2 positions, so over here, what's in for B and C, they actually have a name. All right, and I'd like you to know it. The name of these 2 values that are placed in these 2 exact spots are called the means of a proportion. All right, they're going to be called the means of a proportion. So whatever's in those 2 spots, yes, you end up cross multiplying them, and those are called the means, those 2. And then in the other 2 spots, I'm going to end up cross multiplying 2 and 9 to get 18. Those 2 here, when you cross multiply those 2 values, they're called your extremes. Okay? So they have names. When you I'm cross multiplying the means, I'm cross multiplying the extremes. Now, this is a very elementary school way to remember this, but this is how I remember. Which ones were the means and the extremes? You see how the extremes are going downhill, left and right, left to right, they're going downhill. Kind of like downhill skiing, extreme downhill skiing. That's how I remember it. All right, or come up with your own, I don't care, whatever. Or just make fun of mine later on, whatever. Doesn't bother me. All right, that's how I remember extreme downhill skiing. And what do I need to do with the 8x and the 18? I'm not done solving this yet. What do I need to do with the 8x and the 18? Because I just have them separated there. 24, what do I have to do with these 2? No, even before. Set them equal. Right? I set them equal. And when I multiply the means, what's the answer when you multiply called again? Sum is when you add. Difference is when you subtract. Quotient's when you divide. Product. That leads to the theorem today, which says the following. The product of the means, so when I multiply the means, the product of the means, what do you do to these 2? You set them equal, right? Equals what? Product of the extremes. Yep. And I already know what's going through some of your heads right now. Oh, I hope he gives me a shorthand for this. No. And go ahead, try writing POM equals PO on your quiz and see what happens. Okay, see what happens real quick. All right. There is no abbreviation. Suck it up. If you need to go down to the health office and get ice for your wrist because it's so tough writing all that, feel free. All right. Product of the means equals the extremes. You can't use that, though, unless you have, what did I give you at the very beginning? What was 2 over x equals 8 over 9 called? That's called a what? 5? Yeah, I can't have that. I can't do the product unless I have a proportion. And for Friday, why is the proportion true? Because the triangles are similar. So you see the 3-step process I need to get to here? Prove the triangle's similar. Say the sides are in proportion because of what reason for Friday? CSSTP, and then I can cross multiply. So that's what we're doing today. Take your proofs, go to CSSTP. Let's take it a step further and say the means, the product of the means and the extremes are equal. Look at proof number 1. Everyone see the proof statement? We've never seen that before, right? But what am I asking? Show the product of a pair of sides is equal to a product of another pair, means and extremes. But I still got to show what about the triangle. Oh, there he is. Get it up high. Darn right. I still have to show that the triangles are similar. Darn it, same problem I ran into on Friday. What triangles? And I'm not guessing, and neither are you. How did we figure out on Friday which 2 triangles to prove similar when there's multiple ones in my diagram? 25?
Look at the proof statement.
Okay, name a side in the proof statement.
ER.
ER. Everyone find a triangle? Name it. Name the triangle that has ER. 2.
ERT.
Okay, we're good. James, going back to you. Name the second side.
AD.
AD. Oh, this didn't happen on Friday. Anybody got an issue with using AD? What's my issue using AD? What do you run into here? Which triangle to pick, right? Is it the one on the right? Is it the one on the left? I don't know. You're not going to guess. Let's keep going. Third side, James.
DT.
Well, you skipped over TE, but that's fine because we already had TE, right? So what's the last one?
DT.
Now do you see the triangle we need? The one that has AD and DT in it, which is triangle. Help me out. 11?
ADT.
ADT. Yep. So we got the two triangles. Now you need to find the two angles, right? Well, let's see in our givens. AR is, ooh, you're welcome there, huh? Look at that given. Seen that a few times in this unit. Are you kidding me? TE, I'm telling you that these are right. You don't even need to tell me why they're right angles. I'm already telling you they are. First pair of angles, where are they? Come on, let's dig deep. Where are the first pair of angles up here? Oh, 23?
Angle TER is congruent to angle ADT and all our angles are congruent.
Yes, great job. Angle TER congruent to angle ADT. All right angles congruent. There's one A down. Ooh, need the second A, which is a little bit tougher to find. But I have confidence in you, some of you. 1, 4.
Angle ART is congruent to angle ATR.
Nice job. I got angle R and angle ATR. I'll ask somebody in a second why that's true. Ooh, angle R congruent to angle ATR. How do we get those congruent? 10?
Congruent sides are across from congruent angles.
Only if I have a?
Sausage triangle.
Or
like
just
sausage triangle.
Just in a triangle's fine too. Yep. In a triangle, congruent angles are across from congruent sides. All right, nice job. So now we know the triangles are similar, right? Let's see, what do you got here for me? 23, good similarity statement.
Triangle ADT similar to
ADT
TER.
similar to TER. Let's see if those bad boys match up or what. D, ADT, TER looks good to me. Angle, angle. All right, I can't just go to means and extremes. I don't have any means and extremes, right? I don't have any in my proof to cross multiply. That's the next step, just like we did on Friday. Oh, the triangles are similar. My sides are in proportion. Now it's going to be a struggle now, because usually you would just copy down the proof statement on Friday. So how do I build my own proportion that's going to be correct? Let me give you a little hint. Use the proof statement again. You have to do what? Multiply ER with AD, and they have to be cross multiplied, right? They have to be cross multiplied. Cross. So if you just plop ER in the first spot, which is fine, AD can only go in one spot. It's got to be cross multiplied, right? ER times AD. So where's AD going? Describe 4. Where's AD going?
In the second proportion denominator.
There you go. Whoa, and she used, that was awesome. Use denominator. That makes me happy inside. Little piece of ice melted off my heart. And then what about TE and DT? Doesn't matter. They're just going to be cross multiplied. Why are the sides in proportion again? 8.
Because the triangles are similar.
Yep. And from Friday? We had a little reason here.
CSSTP.
There we go. Corresponding sides, similar triangles are proportional. Now do you see how we're taking it an extra step? Now we can cross multiply. But again, you can't just show the triangles similar to cross multiplying. You need means and extremes to cross multiply. ER times AD equal to TE times DT. Boom. Product of the means now equals product of the extremes. Questions? Are we sure? All right, look, I'm not going to drag this out today. Just want to make sure we're good with our parallelogram properties. First thing I need on your own, you can talk with people around you too, I guess. Find the two triangles that need to be proved similar. Because I got a bunch again in my diagram. All right, what are your two triangles? 16.
Triangle CRQ
CRQ, this one, got it.
and triangle
APQ, good. Anybody have any issues finding those two before we go angle on you? Okay, really, the only given that's going to help is it's a parallelogram, right? So dig deep from your properties last unit. Name a pair of angles you can prove congruent because it's a parallelogram. 6.
Angle QAP and RQC.
Respect. You went to the tough pair. Respect. Yep. Or if anybody saw angle C and angle AQP, these two right here, same reason those two would be congruent. What'd you just give me, Nick?
What do you mean?
What type of angles are these? What'd you just give me?
Opposite interior. Alternate.
Alternate interior. Yep, alternate interior. But I'm not going to write that they're congruent in step 2. They're not congruent yet in step 2. No, come on. We're better than that. Why are they not congruent yet? 8, why are they not congruent?
Because we haven't stated that RQ and SB are parallel.
I need parallel lines to do it, correct? And again, I went back to this on Friday. Sky just gave me the correct lines, but I get some of you still have a tough time finding the lines that need to be parallel. And what's my suggestion? Put both in. Put both pair of opposite sides in if you're worried you're not going to get the right pair. All right, but here it is, RQ parallel to SP. Again, if you're concerned, I don't know which lines I'm going to need, put both in. You're not going to be wrong. Parallelogram implies opposite sides parallel. Now you can tell me the alternate interior angles are congruent. Angle RQ, what's that middle one there? B? RQB? Congruent to PAB? And what's your reason here? Old school reason. 8 again, reason.
Opposite interior angles.
Uh,
In a parallel lines imply that.
there you go. Got to have parallel lines for that statement to be true. Parallel lines imply alternate interior angles. Congruent. Good. All right, we're 1A down, 1 to go. You know, Nick gave you the harder pair. I thought that this next pair would have been easier, but maybe not. Where's the other pair? Well, let me put it this way. Could I just put in these two, the other alternate interior, and we're got angle? Everyone see I could do that too, right? I could just flip it right in here, write those two in here, but I want the other pair. Why is the third pair congruent here? All right. Just to use another parallelogram property. 25.
Angle SRQ equals angle QRA.
Q.
Oh, QPA.
Yep, there you go, right there. I'll ask somebody in a second why that's true. Angle SRQ is congruent to angle QPA. Why is that true? 11.
Parallelogram implies opposite angles congruent.
There's the property I was looking for. Opposite angles congruent in a parallelogram. And there you go. You got your angle. I just need a good similarity statement from somebody in the crowd here. 26, good similarity statement. Triangle.
Triangle APQ is similar to QRC.
How's that look, everyone? APQ. Yeah, that's good. Yep, angle. And also, I didn't mention it in the first one, but just make sure you're putting the tilde, not the congruent symbol in between the two. All right, because I can't help you there Friday. Again, you can't use means and extremes unless you have means and extremes, so I'm going to ask somebody to get a nice proportion here for me. Let's go 23, good proportion here.
AQ
Ooh, going AQ first. I like it.
over QP is equal to QC over CR.
I like it. Reason why the sides are in proportion again, 14.
CSSTP.
CSSTP. And finish it off with your means and extremes, everybody. Questions, comments, any concerns? Giving you half the class now to work together. All right. If you don't want to start with the proof, start with the algebra questions instead. You got 2 of each. All right. You got 2 of each. So if you want to start on the algebra, if you want to take a little break from the proofs, it's your call. All right. You guys can work together if you feel like you need to.